But as you can see, the lines now kind of track with the box, and you can move boxes around. I'm toying with the idea of, let me turn this music down. I'm toying with the idea of having multiple connections like you see here, able to generate configurations. Basically what we have is a set of captures rather than one. So likely what I'll be working on today is getting configs actually generating from the diagram that we've been building. Essentially, if you build a diagram down here, you're able to generate a config and then actually get the extractor working with the configuration GUI. Another thing that has been added was, let me actually expand this. There we go. If I have a capture, a regex pattern up here, there's actually now a slider. So this takes the place of the offset keyword that was introduced a month or so ago. And it essentially allows you to, extend the capture. So that might be useful in finding like a keyword that you're interested in, and then after you've got your keyword, where'd qualifications go? Right there. After you've got your keyword, you can, obviously extend it. I've got a bit of logic working right now where on hover over the any given box, the music is still too loud. Oops, I'm just gonna close Discord. Alright, that's a little better. I can hear myself talking. As you mouse over an input box, you can see how large the offset is and what it's actually capturing. And right now, just base functionality wise, I just want to get multiple captures feeding into a script. I'm not really enforcing any rules about how what needs to go where, but I will do that as soon as I get it working. As soon as I get a configuration generating through the packager and then running with the extractor, once it's compatible, we'll start enforcing what can go where, and then helping the client here basically help the user to make a valid configuration. There's also a few other things I want to work on, such as like a scrollable area down here, because right now you're kind of constrained with how small this area is, but if we can make it draggable, you could kind of move around. And I'm thinking also you can zoom in and zoom out as well. That would be really cool. So that's some functionality that I want to work on. I think I'm going to release version 5, 0.5, with the complete functionality of these boxes. So like once we get things generating and working, I'll make a release, and then I'll do a 5.1 patch, which will add the draggableness and that sort of thing. So that's the plan for today. Get configurations generating from our little visual scripting system here. So we will begin. Something that I have found that's been pretty useful is if I actually split this, I think, oops, there's a control shift. I forget what Terminator's default, so Terminator has a built-in multiplexer, and if I remember how to split vertically, then we can have a npm builds window up here and a Protex process standard out window down here. I'm looking for Control Shift E and then the other relevant command should be there. It's Control-Shift-O. So, cool. npm build, just make sure we can build. Cool. So let's pop open. Oop, I didn't mean to move this to. I didn't mean to move that over there. Move this back to 3. This one to 3. This up. Alright, that's about where we had it, and then we had a little more space for the application. Alright, so moving back over to 2, we can pop open another Protex, go to app, which is our npm project type thing, and make sure we have everything in here and make sure it's clean. Looks good to me. So we can begin by opening up the renderer, which is where our configuration is generated from the client for the most part before it talks to the other process, the main process for an Electron app. So the function in question is GenJSONConfig. So the tricky thing here is I still haven't decided on a format that I want to use for the actual. It'll be JSON obviously like it was before, but I haven't decided on a format in terms of how to represent a step in the configuration, in the category process. Like in our visual scripting system, how do we represent operation A, then operation B, then operation C, and so forth? I'm thinking we just spit out an array, and those are all of our operations, and then have the actual extractor understand how to interpret a set of operations linearly, and that should be good for now. Right now, I believe we're able to get a first operation box, and basically these are op boxes is what I'm calling them, and our first operation box is actually going to be the rightmost box, that doesn't have a write connection, right? Because this is the actual terminator, the terminating box, right? It's the thing that we're done manipulating, we're done processing inputs at this point, and so this is actually what gets spat out of the extractor. So from this rightmost box, we need to go and find its connections, obviously, find its connections, and then start laying them out in the array that we're gonna produce as configuration. One of the more tricky things is how do you manage things like this where let's make another capture. Maybe this one looks for benefits. I added this feature where you can just like select stuff and it'll automatically copy it over to the input over here. I'm not sure if I like it. It's kind of annoying sometimes, and it's a little finicky. But if I think it's cool, and I think I can polish it a bit more to make it not annoying, and I think people could get a lot out of it doing it this way. Benefits. Select that. Sure, and go after that. That looks good. And so I want another connection to this box here. Hopefully nothing broke. Nope. Again, like right to left, it seems to break things, so I need to do a bit of investigation there. Again, qualifications and benefits. So how do we lay out these inputs, right? Because basically we're taking inputs from both qualifications and benefits. In the extractor under the hood, we would be returning two results basically. if I remember correctly. It's been over a month since I've really touched any of that. Or we either break. I can't remember exactly. But how do we manage this in the pipeline? Are these in the array? Do these come like this in this order here? This, then this, then this? Or are these on the same level, kind of like in a tree structure? Like, because here's another totally feasible option where we could have our inputs, actually, our operations be represented as kind of a tree, or a inverted tree, you could say, because it would look, it would actually look, in terms of visual representation, it would look something like this, where we have the actual root at the bottom rather than a tree structure, like this up at the top. So, I guess we could try and encode, like we have level 0, we have level 1, and then operations are kind of represented in terms of levels or rows in the tree, where if we had another step here, maybe this requires a secondary capture, where, I don't know, what is this capturing on? Maybe for the purposes of grabbing the output here, this depends on finding work authorization. So we gotta add work auth. So if this also captures work authorization, then we get to feed into this here. And so the tree structure ends up looking like this, I think. Where there is no level 1 step for this first path, but there is a level 1 step, and this is level 0, level 1, level 2. An alternative is we don't have to think of it as a tree at all, more as just a graph of some sort, where each box actually just has a instead of determining order by actual just position in some sort of data structure, we could have order be determined by an actual physical connection, i.e. this like points to the next operation. So benefits points to a script, like that's the next thing that it needs to do, and capture for qualifications here points to work authorization, which then points to the operation of a script, which, what is this doing? This is just extending the capture by whatever was captured by 100, and then it returns that. What other scripts do we have? We have a potato script which just returns. Oh, that's bad. We should probably remove that. There's no bounds checking on this. This is potatoes version 2. That's what this is. Alright, so I kind of like that, where we have our structure is, we have an operation box. It has all the things it needs to know about, like what its operation is, but then it also has, like, for instance, the index of the next operation, and we can lay out all these operations in some sort of array, right? And they just know about where is the next operation in this array, like what is its index. So I like this, and I think this is what version 1 of this will be. So let's go ahead and implement that. First we need to kind of sort out this nonsense. So we have a conditions as JSON, and again, we're moving away from conditions statements because those are encoded by the operation box contents. So let's make a new, probably new type here, and I've renamed most of my stuff, so give me a sec. Should be in the include file, which we have Protex state, Protex window, xtrdef, probably belongs around here, and we need to export this interface, and we're gonna call it a basically an operation. Just call it an operation step, an op. I'm just gonna say opbox for now. I actually started a bit kind of mapping this out in common.zig to kind of see what this would look like. So it's an op. It was already op, so that doesn't really help. Let's just call it an op. Maybe that's a okay name, and I don't think we'll run into too many issues with just naming it op, because I think everyone knows that, and by everyone I mean me, would understand that op in like a month or so means operation, especially if I stick with this kind of convention. I don't know. We have op. So op needs to represent what exactly? Well, I just had that here, and I kind of started mapping it out. Right now we have two options, which are either a py module or a capture. So basically this points to a this contains like operation data, essentially, either a capture or a py module. And in terms of mapping this over to an a data structure in Zig, you might do something like this, where you have a. I'll try to stick as close to this this representation of the data structure as closely as I can, because it'll make the actually translation of the JSON object into a serializable Zig data structure that much easier. Again, having an operation, you could do something like this, where you have a py module. So this is either a py module, which is, for our purposes, I believe just a py module index. We could do that, because I think the client, the GUI, this thing, understands Python scripts as a, and I think I can just check, because don't I have these already represented somewhere? I've got a script names list, and I can't remember exactly how this guy thinks about scripts. Like, the script selector, I think, just maps an index, and if that's the case, I'll just continue storing the index and call it a day there. Let's look at this one. Content has a script select, and what is its value? The value is value of the script select. The value is the module name, so I guess we're mapping module name to module index, which is okay. That might be the better way to do it in the future as well. So this is either a string or it's null. So that's kind of how we'll mimic the enum type in TypeScript. So it has a set of options. One of them is not null. So there's your enum, or excuse me, union type, basically. Where is, if I go over to the TypeScript documentation, is there an actual union type? Because there might be. Any day now. Maybe. There we go. So I guess handbook, docs. Union. We could try this as well. Does TypeScript support unions? Unions and intersection types. Why? So what? This is a function? What's going on? Gotcha. So, right. Nice. So we can define a type which is either a network state or or whatever our case is, either a Python module or a capture, basically. And these are all different types. Okay. Cool. This is exactly what I want. I think. So we have op. And again, this is just a type. And we'll have our what do I name it? Just apply module op. Already op apply module. Okay, whatever. Can I change these interfaces to types? I've been using interfaces as types, and it's seeming to work well. I'm gonna just follow the... I'm just going to assume that the type op needs to take types. Maybe I'll try it with interfaces in a sec, but... so this is a Py module, op Py module. Or it's an operation capture. Wonderful. And this no longer needs to be null, which is nice. And this needs to be a capture. And I will record the actual pattern as a string. And let's see what the TypeScript compiler has to say about what we just wrote. Close this because it's big. It seems to be happy. And just for curiosity's sake, what happens if we replace interface with type? And I will leave this as an interface for now because I'm not sure what the proper syntax is for this. the Protex window. So just like that. As far as the Protex API goes, I could define it in here and also have the preload include it as well. Just a thought. This is not preload. So here's my Protex API. And this is using require. Right. I'm including it like this. And I guess for this case we could let's try it this way. We don't know what IPC renderer is. I would like to define the shape of this. These are functions that for the Protex API, these are functions that we have somewhere. And I would like to represent those, but they're like opaque. We don't know what they look like. We don't know what they return. We could know what they return. Let's see. How do you represent a? I want to keep this open. Basically, TypeScript. How do you represent a function as a type? This is just telling me how to declare a function. Oh yeah. TypeScript function as an argument, and maybe I can set that as the type. Because normally you just pass the, yeah, of course it's gonna use any. Oh wait. Let's say function. Just like this. So I can say my type is arguments, returns, whatever type it is. Let's try this actually. This is a bit of a rabbit hole, but I think it's worth it. I like to know the shape of my things. So in a Protex API, looks like this basically. We have a get script names function, which returns whatever the IPC. I'm gonna say it returns any. At the very minimum, I just want to have a defined API. It has no arguments. We have a write config, which takes a config string. Write scripts, which takes the script name. Both write and read scripts take the script name. And we have the actual run extractor, which takes two things, config name and text. Again, this is a Protex API. It has these functions implemented. Where do we write Protex API? We just Protex window. This is over in gotcha, we call it through this. Say API, just instead. Is that good enough? I think Protex API is fine. And if I just name this window, is that fine? It's a Protex window. I know I'm getting a bit sidetracked, but it should almost be done. I'm gonna say that's fine for now. And I don't even know if this works yet. But I needed to finish off the other interface. HTML nub is just an HTML element. And this is a type with an equal sign. And these are being comma delimited. Alright, that looks good to me. Let me try to compile. So write script actually failed. Nice. My API is just broken. Source. Type string. What else required to? Just that? Maybe just that. Any errors? 4? Is that all from just write scripts? Looks like it. Looks like we can build. If I go ahead and reload everything, it looks like functionality is there. Of course, I haven't been actually running the scripts. Let's see if I can't write anything. Looks like we can write stuff. If I go ahead and reload again. There it is. And if I just want to return start of to end of, and if I save it. Writing stuff? Yep. Let's go ahead and refresh. There it is. Alright, I'm gonna use the bathroom, I'll be right back. Okay, where was I? This was after, okay, moving all these over to the type, rather than an interface. We now want to treat our operations as a union, of type op. Box with no connections, found multiple end paths, which is okay. And we're going back to the idea of boxes. We're going to represent this as a linear array. Each box type has a basically next index. So let's record that. So operation is a pi module there. Where's op? Well, op is here. And again, just these are the different types that I could represent. So I guess we just slap a next op on each of these as well. I was thinking I could have a whatever type op index, op next op, and then have these like extend that, but that's just complicated and I don't think it makes sense. Basically a next op. This is just a number. Alternatively, we can have a operation. So this is actually the op here. We have some sort of operation data, which is what this would be. So the union is the op data, and the op gets its next op index. Of course, we have data. It's the op data. Let's give this a shot instead. So, no starting op box, we're gonna assert that that doesn't equal -1. And then instead of a conditions is JSON, we're gonna finish our to-do and make this a not stringified JSON object. And what do we treat this as? This is a we don't need a type for this. For right now, we just have we just declare an operations array. This is an array of op. Can initialize it to being empty. Conditions is conditions JSON again. Let's get rid of that. Current op box. We pick out our operation box from the first op box index, which is actually the last op box index. So let's actually just rename that now to avoid confusion in the future while I still remember that fact. And first op. Last op. Not used in a terribly used amount of places. A terrible amount of places. I wanted to use terribly, but I couldn't fit it into that sentence. Last op box index, which is the current op box. So we're gonna treat this as like a queue, or a stack actually. Basically, we're gonna push the current operation box index onto we're gonna push it as an operation onto the stack. We'll record whatever we find next, as well. Do we want to record what's next? We want to travel all, but we want to kind of do a depth first search here, I think, where we travel all the way down to, if we get 3 op boxes in here, left to right, we do a depth first search, and in this case, it would look something like this, where we have our last operation box, which is this. We travel down to here, and then we travel down to here. And the data structure that's produced kind of looks like this, where this is, if this is A, B, C, we end up with something that looks like A, or B, C, A. And B has a, basically a connection to A, and so does C, connection to A. And in terms of how the extractor would consume this, it looks at A, or it looks at B, looks at the first operation. It sees that B points to A. It goes and consumes B. It looks at C. It sees that C points to A. Goes and consumes C. And then how does it treat A? I'm not sure. It sees that it's the last operation. I don't know. We'll get to that when we get to it. But maybe something like that. We'll see. I'm gonna change my color scheme too, because I can. Ooh, this is nice. Spink. Close that tab. We can close this tab soon too, but so what were we previously doing? We were looking at the select type select for each box. and we were starting from current box. Here's another thing we could do. I have an idea. Basically, we need to count the number of unique paths that we have and generate instead of recording an index. Again, we go back to the idea of having the structure of the boxes, the layout of the order of the boxes represents what comes next, because it's just the next thing in the list. And instead of just one monolithic array that's messy and has operation B, then C, then A, or C, B, A, or whatever, we generate multiple operation lists, operation queues, whatever you want to call them, where we have, in this case, we see that there is, basically we need to count the number of leaves, I think, is the actual solution to this. So if we have this here, we would have 3 unique operation arrays that we could potentially output to the user. In this case, A, B, C, D. We would have a B then A array. We would have a, if this is A, B, C, D, we have a C, A, and finally we have a D, A. So these are all arrays, and we need to evaluate each of these during extractor runtime. This solves the problem of, again, having just indices lying everywhere and pointing to the next operation box. We don't have to represent it as a single array. And it looks something like this, where we can now have, again, three unique arrays, and then one of these has whatever that letter is in terms of the diagram. BXA, CA, DA. I like that. So now, we need to figure out how to start building out the arrays. Again, possibly a depth first traversal. So let's actually implement that now. And I think I'm going to just comment this out until I regrok it. Let's get the actual traversal implemented. Traversal implemented. So what I'm gunning for is, again, if this is A, this is B, this is C. We run all the way down to C. We start pushing onto, this is now a queue. This is again a queue. A, B, C. We shift C onto the queue. We pop back up to, if this was basically a depth first traversal is done via a stack data structure, we first push A onto the stack. Then we would push each of its children onto the stack. In this case, it would be B gets pushed, A, B, C, D, E. D gets pushed, E gets pushed. We finished pushing everything onto the stack. We now go and consume, I guess A already got consumed, I think, right? If we evaluate A, B, C, D, or A, B, C, D, E, B, D, E, so A already got consumed. And A got pushed onto our output. Because for each of these, we're looking at this is essentially inside of our loop here. This is going to be our depth first traversal. We look at B, A, B, C. We evaluate B, so we add it somewhere. We get C. We see that C doesn't have any connections, left connections, so we know that it is a leaf. So presumably we've been storing where this came from. I guess we could trace down to a leaf, and then we can trace back up to the root to build up a list of things to do, which is nice because we don't have to do any queue funny business. It's just the order of what comes next? Well, it's this thing, and then this thing. So we trace down, and then we just trace back up to the root. Because that way, now we get to D, which is the thing that's left. We get to D, A, B, C, D, E. We see that D is a leaf, so we build out D, A. And then finally we get to E, we build out E, A. Because, hey, where are your connections? What's your right side connection nub? These are nubs, by the way. These are nubs. Because I think it's a fun name, and it communicates exactly what it is, which is a nub. It was a left connector, or right connector. Right now it's a left nub or right nub. It's like a connector nub. Anyways. Okay, so we need to have some sort of operations stack. I guess this can act as our say op stack. Again, this is also just an array of op. It's uninitialized. And our actual operations is an array of op. Do it like this. I think you do it like this. My nose is really itchy. There we go. An array containing an op array. I think that's how you do this. An array of op array. I think it's just like this is what I need to do. I think this is the correct syntax. Again, it's just empty. And here is our op stack. So what comes first? Well, we need to check for the current op box. In this case, it's the root. And we know that the root op box is actual just last op box index, and maybe we change the name to root, which makes sense to me. So basically, we're gonna push. I believe the MDN for this is just shift. Right. If we shift, can't you provide it with input? Push. That's the end. Shift pushes. This removes. I want to. So wait. Is it unshift? Unshift. 4-5. Perfect. Yeah. So I want to unshift. Basically things onto our op stack. Unshift, and what am I unshifting? Well, I'm unshifting basically each for each child operation. For child operation of our basically current op box dot children. Just current op box dot. Is it indices? I can't remember what I used. Line indices. What is op boxes? Just an array of draggable container. So op box is really an element. Where is this? Is an HTML nub array. Well, an element containing the nub elements of the basically, we have an op box type containing a left nub and a right nub. Maybe I should also do that to do that's me, but of course it has a left nub and this extends an HTML elements as well. I don't have opbox defined, do I? Yeah. I guess prefix it with HTML because it's extending an HTML element. Kind of like that. Where did my music go? Did we finish the playlist? Oops. We did. Perfect. One that's not going to end. This needs to be just like so. Where was I? Oh, I was thinking about, these are just going to record indices, I guess. The op stack is just going to be, indices of, well, I guess I could do it this way. So for child operation of, so this is an HTML, for opbox, just do it like this. So for each one of its children, we're shifting onto our op stack, basically a new op, or op data. What is it? Just op const new op. We're gonna give it everything it needs to know, I think. I guess these no longer have a next index. But an op now has data. For now I'm gonna do this. Because we don't, there in the foreseeable future we might need to extend properties not including data, such as an example is a thing like an index. But for right now we currently don't need to do that, so why complicate it with saying new op, and then giving it a data property, and then giving it a pi module or an op capture. Anyways, moving on. New op. And we give it a pi module. I guess it is a pi module, so we just give it the, oh, pi module type has a pi module, property. Well done, Caleb. So this just gets assigned to a, string. So this is opbox, and this is depending on the type of operation, just like this. So I will do that right here. And we can enumerate by checking the select type of the box. That's what determines its type. In the future, I'm thinking a right-click menu will happen when you right click in that area rather than just creating a box. It'll give you the option for the type of box that you want to create. But the functionality I would like to keep is being able to basically switch the type. You don't have to change the structure, right? You don't have to remove the box, change the type. But the idea that again that I'm going for is instead of just creating a box out the get-go, it gives you a drop down and you say what type do you want? Well, I want a capture or I want a script. Simple as that. And of course this is a script. So let's try building out an example here. And I'll have to do this first. This is dumb. Right now you have to have a script defined. Oh, it didn't nuke everything. That's good. It nukes all your patterns. Another thing that I'll need to do in the near future is save. Being able to save a... Right now you can save a configuration and restore from it. Like we can import a conf. How do you save the actual position of these? I would like to save the position of our inputs at the very least. Get them saving and maybe not saving their position. The saving of positions should actually be trivial. We can just cache the XY coordinates of each box, and yeah, it should be fairly straightforward, albeit annoying. So basically some GUI specific basically data here that doesn't get fed to the packager. And this is for the current operation box. And maybe this doesn't need to exist in a while loop. We'll see. I don't think it does, because we'll be whiling over... We'll be foring... Wait, maybe this will be fine. Let's see. We'll see if this is fine or not. Basically, we have our new operation, so this is what determines this. And regardless, we're pushing on some sort of new operation, so we'll declare it up here. Declare it. And new op in this case is getting assigned a Pi module. Ah. Please paste. Thank you. Next op can go away because it doesn't exist anymore. And we have a pattern. And this gets this. And once we're all done, we're gonna shift the new operation onto our op stack. And of course, if we don't hit any of these cases, we're gonna fall through. And we have basically an array of operations to look at. So we now set the current op box. Once we're done with this, we set the current operation box equal to basically the first item in our op stack, which we're going to pop off. So we're going to shift off the first value. Op stack dot shift. And this doesn't work. We need to, we actually need to shift the index on down. Let me do... I guess I could have a loop up here that does what this was doing, where we're building out a, basically we build our op data structure, our op box data structure. When iterating over here, we could also record the index, so i.e. child indices dot entries, so opbox and opbox index, and then instead of representing a op stack, this is just op stack indices, op indices stack, opbox opbox indices stack. It's an array of that. So this is last opbox index. That's what this gets to initialize to. And then operations. So again, let's walk through this. We're just trying to traverse down to the leaf. So what this is doing is we're, again, evaluating the value. We're determining what kind of operation to make. And maybe that doesn't need to happen yet. That needs to happen when we traverse back up. Not now, I guess. So let me turn down the music just a tad again. Also do it via my interface. It's still just a pinch loud. Maybe I'll just find a different playlist. Get some space lo-fi. This is a little better, a little quieter. So, right, we're gonna want to do these steps when we're looking back up the tree. So we don't need select type select yet per se. And this becomes op stack indices, opbox indices stack. And this is, of course, the op boxes at this position here. So we're going to shift on the index, and we need to actually grab each box, but we need to do that by actually asking for entries, and I'm going to source renderer. I've done this before. Let's go find an entries. Index comes first, then it's followed by the value. So for opbox, index followed by opbox, just like so. So for each one of the entries, we record the opbox. We're unshifting opbox index. onto our indices stack, we're unshifting it, or we're shifting it once we exit out of the loop, and this will start the next iteration over the current op box, which will push all of its children on again. And let's just move all of this out of the way for now, because this will happen down here somewhere after we want to check the after we trace back up to the root node, root operation box. I missed a closing bracket somewhere. Guess that'll become apparent once, oh, is it here? Yeah. It's the end of that switch. Right, so right now we're just popping off the index, and we're shifting on all of its entries from the root node. So shift all of its indices on, set current alt box equal to the first one, and we're going to repeat that process until we encounter a leaf node. So while we have alt box, we need to check its left and right. Draggable container connector right. I have a function for getting the left and right, getting nubs from container. So who is calling nubs from container? Box is just the type. This looks like the same context of how I was using it. These are draggable containers. Nice. Yeah. Okay. So what was going on up here? Oh, we were using this to compute the root. Okay. Well, I guess kind of more of the same thing. So strip left nub and right nub from the current operation box. We now have these, and what are we interested in? Well, we're interested in if it doesn't have any left. Was I trying to get line indices off of a box? That's not going to work if I was. I think I was trying to do that down here. So if left nub dot line indices is empty, then from here we need to trace back up to roots and append a new array of operations. Basically, we need to append to our operations array a new array of op. Otherwise, we keep, then we continue unshifting. Basically, if the operation stack is then empty, and when is it empty? It's empty when, if we have one more element and it's the last element, basically this is the last child, we unshift it, there's no more things to shift. So if this is empty, So if performing this operations, what is returned when shift is done? I can just go to a, just like this. So if I have an array of 1, I ask to shift it, I get to that. If I shift it here, what do I get? Undefined. Just undefined. Okay, well, I guess we just check the length before we shift. I didn't know if that was gonna give me like -1 or null or something. So next index, it's whatever that is, and if it's either a number or undefined, we can check if not next index, then we're done. So that should take care of actual loop termination once we've exhausted all of our indices there. I think this is good for an undefined type. So it's either number or undefined. I don't know if you can kind of coalesce undefined and null. Maybe you can, maybe you can't. But we'll find out once we hit the build button. But again, back to this other case where we have a empty set of left nub line indices. We need to follow back up to the roots. So in this case, we while over all of its right indices. So we trace from left nub or right nub, and we should probably assert that right nub has line indices, but we're asking for its first line indices there, because I don't know that right nub line indices can have multiple connections. Again, I need to flesh this out. I mentioned that earlier. So let's basically assert that it's greater than 1. Say greater than 0. Let's just say equal to 1, because I think I want to enforce that. You should have at least 1 blah 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 right nub line. I'm just gonna say expected length. So 1. Just like that. So check that it has at least 1, or it has 1 line index that it points to. Wait, is this how I have to iterate? Because in the past, the line indices only reflect the, well, line indices, and basically I need to find the next box. So this is a find the next box function. That's annoying. Maybe I need to tweak how we're caching box indices. But get box from line index is the function I need to write, essentially. Again, to do, I need to make this an HTML box, the HTML elements, because it contains specific things. Well, does it contain specific things? It contains its contents element contains a left nub and a right nub. This is like 3 tabs over? Yeah. So next box index is 0, or is -1, box index is 0. We have a target. Basically, we have right line index is our line index. Box from right line index is what this function is doing. I guess I'll also pass it the boxes. Ah, there we go. And down here, to ask for box from right line index. So here's where we encounter our leaf. We need to check that the length does not equal 1. We find the right line index, so this is the op box. Here's the parent op box. Do it just like this. We need to also pass it op boxes. This is over my requirements for new line. Let's do it just like this. So we derive a parent op box. We check that the parent op box. This is while parent op box dot left indices or right indices. We could also do it this way too. So we go and derive a parent op box. We have a condition for if parent op box. We append it, or more accurately, unshift. Here's where we would be creating the new array. Operation queues. The QUEU? Q? How do you spell Q? QUEUE. Basically operations at an operation is it push? We're gonna push a new array. After we're done here, we need to increase the amount of do that inside of here once we encounter a leaf. We can also not record the number of operation queues by making it saying new operation queue. Just initializing it like this, and then we operations.push. Sort of like this. So here's our new operation queue. We're again tracing back up to the root node. We derive the parent op box. We shift the unshift. Are we pushing or unshifting? I think we're just unshifting. No, we're pushing. Basically, you operation queue dot push operation list, operation array, whatever, no operation queue, because it's in order going from next operation to next operation. We're pushing some sort of operation, and that is where this comes back into play. Just like so. We are pushing the new op. And then finally, if the op box is dot write parent op box, we need to get its we need to get its line indices. Do we ever care about left indices? We're always asking from the right side, so basically the next right nub index. Say we'll need to update after this needs to happen at some point, basically. I don't know how you discard things. I think you can discard things like this. I don't care about the first element. Maybe TypeScript will complain, who knows. Again, nubs from container, op box. This is just parent op box. And this then becomes the parent right nub. And I can do this via declaring a this needs to be an HTML nub. Just declaring it. It's undefined. We assign it here by getting nubs from container. And via the parent right nub, we check zero, then we are done. We have hit the root. We could also do a comparison against the current operation or the last op box index, and that would also work. I'm just going to note that to myself. We could also compare HTML elements, and that would be sufficient, it seems. Gosh dang it, that's over too. Alright. I try not to go over 100 characters per per line in terms of width, so 100 columns per line of code. Just to keep, it's just the magic number that I picked, so that I could keep things consistent in terms of how big is my text editor, right? Font size, etc. And that's a little too big. How about that? Alright, so we just encountered a leaf. I recorded the parent right nub. I do it by stripping it out of nubs from container. We check that the parent nub line indices length is 0. We hit the root and we're done. This is after, of course, we push the new operation, which is derived from the parent operation box. And this is off of this. I'm trying to do this from current op box. Legacy code, legacy code, legacy code, legacy code. Pushing conditions, I guess. I might ditch the whole conditions or categories thing and say an extractor is just whatever you've described in the GUI here. This is an extractor. And conditions are simply just the conditions gets replaced by an operation queue. A set of operation queues, potential operation paths you could take. But let's kind of review what has just been written. I don't need this set of operations. We have an op box indices stack. We have our current operation box. We look at the index and the operation box. We get the left and right nubs. Since we're currently looking at the root, we don't execute this code path. Don't go down this path. We unshift the operation box index. which in this case is 0. Well, it should be 0. So we unshift 0. Well, what is our... I don't know that I'm starting from the root. Which may be fine. Is that fine? In this case, I could be starting from any one entry. So with this logic, I'm starting from any potential entry. And that is fine, I think, because we're going to evaluate, we're going to find roots. We're going to shift up to the box. Do I need to find? I might not need to find the root to begin with, actually. So we get our out boxes. This is code for finding the starting box. So am I even using, I'm not even using, wait, well, I am getting left nub and right nub from outbox. Okay. So current outbox doesn't even make any sense in this context. I don't really know that we need this either. Or we're unshifting up into C stack. And at this point, why are we in a true loop? I don't know. So we get simplified down to this, where we have our operations, array of operations. We have our op indices stack, which I think can go away. I really liked the name of that too, so that's kind of a shame. Regardless, we take a look at op box entries. We get a left and right nub. This isn't a, let's pretend this isn't a leaf. Or maybe it is a leaf, I don't know. Let's pretend it's a leaf. We're going to say you have a right line index. We're going to say, what is your parent op box? We're going to get that op box. We're going to get the right nub from your parent op box, which we use there. I do need this. I do need this to be a true loop, so that's cool. Or a while loop or whatever. So yeah, if our parent write nub, and does this need to be only using it there? Excellent. So I can get rid of it. Say we're done, exit the loop, push the new operations queue for each iteration of encountering, for each time we encounter a leaf, we're pushing a new operation queue. And getting into the nitty-gritty details of building up an operation queue, we need to first make an operation. So we've just found a new one. Again, we're checking that it has a write line. And of course, once we encounter the last one, we're not going to execute this anymore. We're done. We could do it like this. So I found a root. So while we haven't found the roots node, we're going to continue searching. Yeah, we could, but I'm just going to do that. We are done. Okay, so while we haven't found a root, we're checking that it has a write line to travel to. We get the parent operation box from the write nub line indices. We get the type. We switch on its value. And then depending on the type of box that we're dealing with, we're gonna push on the appropriate object. Finally, we're done with creating a new operation, so we push it onto the operation queue. We check that we're not at the root, and if not, then rinse and repeat by traversing to the current from write nub line indices. Write nub line indices. Should be parent write nub, right? Right? Well, we haven't found the roots. Yeah, so this isn't going to work because we need the correct write nub to be assigned. Parent op box is just the current op boxes. We need the previous parent op box Yeah. Whatever previous parent was. Oops, just like that. So we need to get that. So parent outbox, parent write nub, like that. So this is new parent outbox. Just go ahead and declare that. So we check. From the currents, so I guess parent opbox is, I guess we make this current opbox, right? This is the current opbox. Because this is kind of misleading, because here this is just the first element. Right, so this becomes current outbox, and we assign this to outbox actually. Alright, so get the current nub from the current operation box, and I will do index. This is just I guess that's fine. I would like this to return an index in the future, maybe. This is okay for now. Left indices length is 0. We encounter a leaf. We're gonna say, here's our operations queue. Here's our outbox. We haven't found the root. Our currents. Here's the current write nub from the current operation box. So we get its connections. So select type select. I don't need this yet, do I? Boom, so we found a leaf. We get its contents, build the appropriate operation. We push the new operation. Now we're checking. Now we need to basically move to the next. Move to the parent outbox. So we get current write nub. We set current write nub equal to this is fine, I guess. We assert that it has a current write. Well, we don't assert this yet because actually we don't assert it at all. Is not greater than 1, basically. Also want to enforce that it's a valid index, or it has a valid length, so either it's less than 1, less than or equal to 1. Either it's equal to 1 or it's equal to 0. Again, just enforce that write nub indices are just a number, and I can enforce that with the data structure as well. So I might do that in the future. So enforce that it's a 1 or a 0 for the current write nub line indices. If it's 0, we're done. Otherwise, assign a current outbox from the write line. We could also just break, skip out on another variable declaration, and skip out on this else block, but this is fine. I kind of like having this while we haven't found the root. It's expressive and it gives me a hint about what this loop is going to be about. But that is kind of misleading because it's more than just finding the root. Well, not really. We found a root, we're done. We push to the operations queue. I think this should be enough. I would like to change the name of this though. Like the current outbox is misleading. It should be. It's not misleading, but it is. You know what I mean? So we have two current outboxes. We have the outer op. We have the current. We have outbox A and we have outbox B. We have an outer loop and an inner loop, which is meshing. My names are colliding right now. I could encapsulate this in like a function that says build me a operation queue from leaf, something like from leaf How does this feel? Why is this opbox versus operation queue? I don't know. So here's our new operation queue, current outbox. This is initialized to the leaf outbox. Returning the new operation queue. Nice and folded into a glorious function. operation, we're pushing an operation key from the leaf, and for now I'm just going to console.log operations and see in how many ways this is broken. That's pretty good. Well, maybe this is just syntax, and then maybe we get other errors. Lines 19. Yeah, so that was just a case of me zigging the array. Zig does arrays backwards, or array declarations backwards, or slice declarations more accurately. 58's not happy. Why are you not happy? Oh. That's why you're not happy. Because you are inside of a function call. Of course, I now need to include op in my wonderfully long list of imports. Probably wants a few other things too. Can I make... Oh, yeah, I figured that would happen. Wait, do I even need the index? I don't think I even need the index. Cool. So it's just unused. Great. Probably did that somewhere else too, right? That's of type elements. Fine by me. I think opbox from right index is also angry. This needs to be an element. This returns an element. I have declared it. TypeScript. Can I initialize it somehow? This is bugging me so much that I'm gonna do this. Is this worth the performance hit? I don't think so. Basically what I was going to do is I was going to say init my thing. It was going to take any type, and it was going to return the, basically this. Is there a way to do like a macro in TypeScript? Can I do something like that? TypeScript macro. I'd like to know how to declare a oh my god. Declare a TypeScript. I just have to call its constructor. What's a definitely type? Huh. Maybe I'll check that out in the future. Can I just do this? You know what, screw it. I'm gonna do this. And this is being used as a value here. So how do I pass a type? T of type. What is a type? I guess I can just say this is a type, right? Type of S. But this is a type. You say this is a type? Can I do that? I don't think I can do that. Be surprised if I could do that. Wait, did that work? No. And it's not the type of op. I would like to pass the type generics. Ah, just like that. Just like that. Just like you would in a sane language. And how do I call it? Yeah. Just like that. With that broken syntax. Is that my latest build? What do you mean? Op isn't void. What else do you need? You might need, might need those types as well. No, it's still angry. Oh. Yeah. Yeah, I'm an idiot. That should be that. What do you mean this comparison's unintentional? I'm comparing a length. It's a number. The heck? That should be an OR for starters. So whoever's calling Operation Q from Leaf also needs to pass the oops. Pass odd boxes as well. $102. So the moment of truth now given to boxes. Let's get a capture going. Qualifications. You are a capture. Qualifications. You are a script. Pressing the run button currently does actually nothing. Why? Should be console.logging operations. Oh, because I don't have a current extractor. That's annoying. Potato. Where are we asking for line index? Oh. Yeah. So get an auth box from the right line index. I'm saying left connector is which left line index are we checking? Well, we have a target. We're checking all of them, right? This was assuming, this logic was assuming that there was only one index per line, but for each box, we need to check each box's for each one of these line indices. So we don't need that check anymore because it's impossible. And these are already numbers, so we don't need to worry about that becomes right line index. And this is now over 100 columns, so do that, I guess. Actually do this. I guess that's better, I don't know. Auth box from right line index, so now we say result index, box index. We get the left nub, we ask for its line indices, we're looking at each line index. We find the left line index, we find our right line index. We record the index, and we are done. We could also just do this. No left line index matching right line index. And TypeScript will probably complain. Let's do this. Well, let's see if TypeScript complains first, then I can try what I was going to try. So for each box, for each left nub, does it have an index that matches the right line index? If it does, we're returning that box. Otherwise, we're angry and we're going to assert false because we didn't find what we were looking for. I'm cool with doing it this way, element or undefined. Oh, but then does it get mad that I'm not treating it as undefined? Current opbox, can't find the name. This is opboxes. This becomes box. Give this another try. This is why saving configurations is so important. It'll save me all this time of doing this. You are length 1, and it contains a pattern for qualifications followed by a script, which is exactly what we wanted. What breaks when we have something else? Hopefully nothing. Benefits. You are a benefits capture. You attach to scripts. I clicked the wrong drop down. Did I click the wrong drop down? Oh, I clicked that. Qualifications followed by a script. This should be benefits followed by a script. Wonderful. All right, sick. I think I'm going to take a bit of a break and be back on a bit later, but first I will commit my code. Protex renderer clue.ts. and this will have commits for basically build this is update GenJSONConfig to work with the visual scripting system. All right, wonderful. I will see everyone in a bit.